All right, let's talk about something you probably interact with every single day but never really think about: packaging. We're going to pull back the curtain on the invisible system that makes sure the boxes and containers for your food, your medicine, and pretty much everything else are actually safe and reliable. It's this whole world of stats and standards that's quietly working in the background. So let's dive in.
Okay, picture this. You're in charge of a factory that's pumping out 1 million, say, cartons of milk a day. 1 million. How in the world do you check every single one? A tiny misprint, a seal that's not quite right, the wrong expiration date. Any little thing could be a huge problem. So how is it even possible?
And that really brings us to our first major hurdle, this massive, almost mind-boggling challenge of what we could call the impossible inspection task.
I mean, let's be real. Checking 100% of anything at that scale, it's just not going to happen. It would cost a fortune and grind everything to a halt. And yet, we trust it, don't we? You trust that pill bottle is sealed tight, that your food packaging hasn't been tampered with. Well, that trust isn't just blind faith. It's built on a really, really clever system.
And that whole system, it's all built around this one powerful idea that works kind of like a statistical shortcut.
So, the big secret is something called AQL, which stands for Acceptance Quality Limit. The best way to think about it is like a political poll. You don't have to ask every single person in the country to get a pretty good idea of an election result. You just have to ask a small, random, but representative sample. AQL applies that exact same logic to manufactured goods.
Okay, so here's the official definition, straight from the international standard. And the key words here are index for a sampling plan. Notice it doesn't say quality guarantee. It basically represents the worst-case quality level that's still considered okay. It's the line in the sand that helps you decide whether to accept or reject an entire truckload of product based on just a handful of samples.
And this is absolutely crucial, so let's be super clear about it, because a lot of people get this wrong. AQL is not a promise that a batch has, say, 2.5% or fewer defects. It's a statistical tool that tells you how to set up your test. It guides the decision. It doesn't describe the exact final product.
And, the system is smart about it. It has different tools for different jobs. AQL is what you use for your regular, ongoing business with a supplier you work with all the time. But what if you're just doing a small, one-time order or a test run? Well, for that, there's a different tool called limiting quality, or LQ, which is designed precisely for those isolated cases.
You're going to see numbers like this one, 2.5, all the time in this world. An AQL of 2.5 is a super common benchmark for what are called major defects. Things that might actually affect how you use the product. Based on this number, an inspector just looks at a chart that tells them, okay, for a batch of this size, pulled this many samples, and if you find more than this many defects, you reject the whole lot.
But here's the thing. It's not just one check and you're done. No way. A really good system has multiple layers of defense. Think of them as the 3 gates of quality.
And that makes sense, right? A smart system doesn't wait until everything is finished and packed in a box to find a problem. You want to build checks in all along the production line to catch issues early, back when they're way easier and cheaper to fix.
So this process has 3 main stages. Gate number 1 is receiving inspection. This is where you check the raw materials, the paper, the ink, the glue, before they even hit the factory floor. Then you have in-process inspection. This is monitoring things as they're being made, catching stuff like a machine slowly going out of alignment. And finally, you have that final inspection, the last line of defense. That's the AQL check on the finished goods before they head out the door to the customer.
So this system is fantastic at finding problems, but finding them is only half the battle. What happens next is what really counts. How do you go from spotting a defect to making sure it never happens again?
This is really the moment of truth, right? The inspector pulls their sample, they find too many bad ones, and boom, the entire batch gets rejected. What happens now? You can't just throw it all out and cross your fingers that the next one will be better.
This is where the real intelligence of the system kicks in. It's a process called CAPA. That stands for corrective and preventive action. This isn't just about catching mistakes, it's a formal, documented way to dig in, find the real root cause of the problem, and fix it so it's gone for good.
And the workflow is just so logical. Step 1, contain. You gotta stop the bleeding.
Isolate the bad batch so it doesn't go anywhere. Step 2, analyze. You become a detective. What really went wrong here? Was it a bad batch of ink, a machine setting, an operator error? Then you correct the root cause, not just the symptom. And finally, and this might be the most important step, you verify. You run tests, you gather data, and you prove that your fix actually worked.
Now, this whole system we've been talking about, AQL, inspections, CAPA, it's not a clumsy, one-size-fits-all approach. It's actually really smart, and it adapts based on the product itself.
Which, when you think about it, makes total sense. The amount of risk tied to a pharmaceutical package is worlds apart from the risk of, say, a box for a kid's toy. So the system gets stricter for higher-risk products. The rules change, especially when it comes to things like how long you have to keep backup samples.
And you can see exactly how this works in the real world. For pharmaceuticals, the stakes are so high that in the US, the FDA says you have to keep reserve samples for a full year after the drug expires. For cosmetics, international standards recommend keeping samples of the finished product. But then look at food packaging in the EU. There, the big focus is less on holding samples and more on perfect traceability, so you can track every single component back to its original source if you need to.
So when you zoom out and look at the whole picture, you see it's not just a simple pass-fail game. It's this dynamic, living system. It uses statistics to be incredibly efficient, it uses layers of inspection to be tough, and it uses formal correction to constantly get smarter. It's really a language of trust, spoken between suppliers and brands all over the world, and it's all designed to protect us.
So the next time you pick something up off a shelf, just take a second to look at the package. Is it really just a box? Or is it the final, visible piece of evidence of this incredible, invisible, global system of trust that's working silently to keep you safe?